So today's video is on significant figures. Significant figures can be a bit difficult for students because it's very difficult at first to wrap your mind around what they are really for. So when we think about any kind of numbers, we have two kinds, exact numbers and measured numbers. So exact numbers, for example, would be like these boxes. We see on the slide that there are exactly 4 boxes. There's no doubt about it. We can count them. There are exactly 4. Where significant figures comes with inexact numbers, so things that we measure. So for example, I now have 1 box. In any exact number, there are no significant figures because we know their exact amount. But if we're trying to find the length of this box, we have some kind of inaccuracy and imprecision. So in this case, if I have this centimeter ruler and I'm trying to measure the length of this side, what we end up looking at is we have this ruler that's pretty inaccurate. It only measures to the centimeter, to the ones place. So what I would have to do is I would have to approximate 1 degree past this. So if it's at the ones place, I'm approximating to the tens place. So just eyeballing it, it appears that it's 0.4 centimeters. But if I increase the precision and accuracy of my ruler, we see that I can make an even better measurement. So now I have centimeters divided into tenths. So we see that what I can do here is instead of measuring 4 tenths, because obviously I was incorrect with my first measurement, I can now approximate 1 degree further. So my measurement here would be probably 4.8. So you notice in each case I'm adding 1 decimal place more of accuracy. And then if I get an even better tool, we can see here, I now can go even 1 degree further. So instead of the hundredths place, I can go to the thousandths place. So it looks almost like my measurement is 4.8 or 0.48. And then somewhere in between these two hash marks, it's too small for me to make a observation. So I'm going to guess that it's in the middle. So with measured numbers, as we see in each case, there's some degree of inaccuracy, and we have to reflect that and account for it through the concept of significant figures. So again, it's to show the limitations and imperfections of measured numbers. Exact numbers, things that are counted, have no limitations, no imperfections, so they don't have significant figures, but measurements do. So we primarily use significant figures when we're dealing with measuring devices. So we have this beaker, for instance. The beaker is calibrated to the tens place, so I have to go 1 degree further to estimate its quantity. So I'm going to look here, it's between 40 and 50, looks a little less than a half, so I would estimate that there are 43 milliliters in this beaker. Looking at this graduated cylinder, we read from the bottom of the meniscus, and we see here that we're going up by ones. So instead of measuring to the ones place like we did in the previous one, we're instead going to estimate to the tenths place. So this looks like 35.4 milliliters. So hopefully you're noticing that in each instance, I'm estimating 1 degree past my level of certainty from the calibrations on the tool. We even do that with a ruler. So if I'm measuring this pencil, it's measuring in centimeters. So I have to go 1 degree past the ones place, which is the tenths. So this looks to be 15.9 centimeters. And we even have this when we're measuring with digital tools. So this digital balance builds in a degree of imprecision. This place right here, because of significant digits, because we understand that all measured numbers have some degree of inaccuracy, we know that that 800ths place is an uncertain value. It's estimated by the digital balance. Now, if we're looking at numbers, so the measurement's already been made, we can tell the accuracy and precision of that measurement by the following rules. This is where it kind of gets tricky for students. The first rule is pretty straightforward. Anything that isn't a zero is significant. So we see here, 1 meter, this digit is measuring something, so it has 1 sig fig. I like to abbreviate significant figures as SF because it can get a little bit wordy. Now the next rule is another easier one, but it adds complications. Where we really have issues with sig figs comes with measuring zeros. Sometimes we use 0 to measure a quantity that is absent. Sometimes the 0 is simply there to hold a place. So there's a big difference between something that's measured and something that's just sitting there holding a place. So we see here, we're measuring to the ones place. We have measured 100 meters. Because the 0 is in between two significant figures, it also becomes significant. So I've measured something in this place, but I've measured that there's nothing there. I also like to call this the smiley face rule because I like to underline my significant figures and then I draw a line connecting them and always makes a smiley face. So we see for this one, we have 3 sig figs. The last one is probably the trickiest of all, and that's the trailing 0 rule. So if you ever have a number with a decimal and it has a 0 all the way at the end after that decimal, that 0 is significant. So we see here, we have 0.0 at the end. It's a trailing 0. It's all the way at the end, and it's after a decimal. That is significant. Then just like the number before, we see that these 3 digits are significant. So in total, all 4 of those digits are measured. We have 4 sig figs. That's different, though, than if you have a trailing 0 without a decimal. So we see in 100 meters, this 0 is trailing, but there's no decimal. The issue arises is we don't know if anything was measured there or not, in the ones or the tens place. Because we are more skeptical that a measurement is inaccurate and imprecise than being accurate, we can't certainly say if it's significant or not, so we err on the side of caution and instead say there's only 1 sig fig. If any rule is going to give you guys difficulties, it's going to be this one. Another thing that's important to know is, let's say that 100 meters, you actually did measure to this ones place. The way you can modify and manipulate the significant figures is by using scientific notation, as we'll see here. So we see this number below, 7.00 times 10 to the negative 10 seconds. These zeros, if we just wrote it as 7700, it was a whole number, it was 7,700, and we didn't worry about this part, they wouldn't be significant. But because it's in scientific notation, everything to the left of the multiplication symbol is significant. It is measured. So let's say that we wanted to get rid of some significant figures and we actually didn't measure to these places. When we'd write our number in scientific notation, we would simply omit them. So it's kind of difficult at the beginning to track sig figs in numbers, but once you get the hang of it, then you actually get to apply it. So we've seen it applied by actually measuring using different tools, but now we also will need to apply it through calculations. So we have 4 mathematical operations. We have addition, subtraction, multiplication, division. Each pair has different rules to abide by. So the first one, when you're adding and subtracting, your answer needs to be rounded to the least decimal place from the numbers you're working with. So all of this can be done mentally, or you can write it down before you even do your addition or subtraction. So I see here that I have the hundredths place in my first measurement, the tens place in the other. I have to show that my weakest measurement, my most inaccurate one, and I need to reflect it in my calculations. So I go through the math, I find out that our answer is going to be 3.41 grams. But what I need to do is now round it to reflect that tenths limitation. So I see my 1, it ends up rounding my 4 down. So my answer would be expressed in appropriate sig figs as 3.4 grams, not 3.41. With multiplication and division, the rule is slightly different. What we end up seeing, because of amplification of inaccuracies, where instead of rounding the least accurate place, we round to least number of significant figures. So looking here at this number, 3.777 grams, there's 4 sig figs there. The measurement in the denominator only has 1 sig fig. This is my limiting measure, so my answer is ultimately going to be rounded to 1 significant figure. So on this slide, I have a bit of practice that I'd like you to try and do now. So on the left, we see we have significant figures, just simply identifying them. And then on the right, we have calculations, so we're actually applying it. So what I'll do now is give you a little bit of time. You can pause the video, try these out on your own, and then I'll provide the answers at the end. So we see the first one is 6 significant figures. All the digits are significant. The next one looks like the trailing 0 rule, but isn't. So what we see, this last 0 is not necessarily measured, so we omit it. We only have 2 sig figs. As we see with scientific notation, we have 3 sig figs there, everything to the left of the multiplication symbol. We have a big sandwich rule in number 4. The 3 and the 2 sandwich all the zeros in between. And then in the last one, we have 3 sig figs. All of these initial zeros are merely placeholders. They have no measurements, there's no measured quantity. They're not measuring that there's nothing there. These are though, and so is the 3. So it's 3 sig figs. Now in our calculations, the first answer is going to be 40 meters squared. So if you do this in your calculator, you get 36. But if you notice, both of your numbers have only 1 significant figure. So your answer must be rounded to 1 significant figure. A lot of students at this point, they'll see 36 meters, and they'll want to round this to 4 meters squared. You can't have a number all of a sudden change its value that drastically. Just because you round it doesn't mean that that entire digit disappears. So you still, when you round this up, you round it to 4, but that's 4 tens. You need to indicate that you have no 1s, so it becomes a 0. Watch out for this. In addition to the trailing rule, that's probably one of the most commonly missed significant figures calculations. Now I'm going to go through with the next two. We see that we have our least accurate place of measure in the subtraction is the hundredths place, so our answer needs to be rounded to that. The next one, or the next two actually, we start seeing multiple calculations, and you have to mentally track where your sig figs go. So I see here my number is probably going to have 3 sig figs, because it's going to be rounded to the hundredths place. Actually, might even have more, might have 4. But I know that I'm going to be limited by the 3 sig figs as the denominator. So that's your answer there. And then the last one, we have 4 sig figs on the top, because of 4 digits, all are non-zeros, 2 on the bottom. So when we simplify that, it needs to be down to 2 sig figs. So I hope you guys found this significant figures video helpful. Hopefully at least it clues you in on some problem areas that you might want to look for and get some extra help from your teacher, extra practice online. So thanks for watching.